Alright, hello everybody, and today we're going to be having a look at the Pythagorean identity. And what exactly is that? Well, as the name suggests, you might think that it's related to right angled triangles. And in fact, that's exactly what it is. But in order to derive that, we need to have a look on our unit circle. So this is our unit circle, and let's say we make some angle theta to the positive real axis right here. And you see we have this point right here on our unit circle that corresponds to that angle. And we want to figure out what exactly the x and y coordinates of that point are. Well, let's say that point is called P. Well, we know from the definitions of the unit circle that has an x coordinate of cosine of theta as well as sine of theta, whatever theta happens to be. So that means we can construct a little right angle triangle right here, and we have the value of the side length being equal to cosine theta and this other side length being equal to sine of theta. And notice that we're working on a unit circle. That means the radius of the circle is exactly 1, but notice the hypotenuse here is also the radius, so that means the hypotenuse is 1 as well. And let's use Pythagoras' theorem to kind of relate the sides of this triangle together. First of all, we have the sum of the squares of these two sides right here. So we have the cosine of theta, the whole thing squared, plus the sine of theta, but the whole thing squared, being equal to the hypotenuse squared, which is exactly 1. And we're almost there because we can actually rewrite this a little bit. If we have cosine of theta, but the whole thing squared, we can actually write it as the cosine squared of theta. It's just a bit of a neater way to write it without brackets. And then we can add it with the sine squared of theta, and that gives us 1. And this right here is the Pythagorean identity. So this identity holds for any value of theta on our unit circle. And you see we kind of have this nice relationship between the sine and cosine. And we can in fact rearrange this like any other equation to get cosine in terms of sine and vice versa. So if we rearrange this equation a little bit, we're going to get cosine squared of theta being equal to 1 minus the sine squared of theta. And you see cosine of theta squared, we can take the square root on both sides. And don't forget the plus or minus. And you see now we have a cosine in terms of sine. And an important thing to notice is there's a plus or minus sign right here, and this will change depending on which quadrant you're in. So in this case we have the cosine, and you would choose the plus if you're in the first or fourth quadrant, or the negative if you're in the second or third quadrant. And you can do the exact same thing for sine. You're going to get sine of theta being equal to the plus or minus square root of 1 minus the cosine squared of theta. And yeah, you have these two equations where you can express the cosine in terms of sine. And this is nice, especially if you have questions where you're given that, well, sine of theta is equal to 3/5. Well, let's say theta is just between 0 and pi over 2, so the first quadrant. And you're asked to find what exactly is the cosine of that same angle theta. Well, instead of working out what theta is equal to and then plugging that into the cosine, we can just use this little identity right here. So we know what sine of theta is equal to, and we want to find cosine, so why not use this first equation right here? So that means the cosine of theta, that's going to be equal to the plus or minus square root of 1 minus the sine squared of theta, which is 3/5 squared, which is nothing but 9 over 25. And then let's turn this one into 25 over 25. 25 minus 9, pretty sure that's 16. So we're going to have plus or minus the square root of 16 over 25, which turns out to be plus or minus 4/5. And how do we know if we choose plus or minus? Well, notice we're in the first quadrant right here. So that means this cosine, this quantity that we're interested in the first quadrant, cosine is positive. So we can actually ignore this negative value, and we're going to get 4/5 out of that. So that's just a nice application of this Pythagorean identity. But yeah, that's pretty much all for this video, and I'll see everyone next time.